Hi guys, welcome to statistics. So, in terms of the exam skills, you need to be able to select and use the chi-square test, student's t-test, and correlation coefficient. So we will start this actually with the standard deviation because we did do some work on standard deviation in section 4, but it's good to recap on it. So standard deviation, if they don't overlap, okay, there is a significant difference between the things that you are comparing here, and there is less than 5% probability that the difference is due to chance. So the words, obviously, it's not due to chance, but this is the wording the examiner would like to see from you. So there is less than 5% probability that the results are due to chance, or the difference is due to chance. But when the standard deviation overlap, as we can see here or in the table, there is no significant difference between the values, between the things that you are comparing, and there is more than 5% probability that the difference is due to chance. So make sure you get along with the terminology. Another thing that you need to be aware to use is the chi-square test. So chi-square test is one of the statistics tests, and to analyze and recognize the test, you are looking for the number of individuals in specific categories. So this and individuals, okay, in categories. If you see something like that, then you're using a chi-square test. The chi-square test, to work out the chi-square value, you need to be able to use the equation, which is the sum of observed minus expected values square divided by expected values. So you need to know this formula. So what do you do then? So once you've calculated your chi-square using this formula, you are going to then work out the degree of freedom, which is n minus 1, where n is a number of cases. So for example, if you were tossing a coin and you were looking at the heads and the tails, the number of cases here is 2. So your degree of freedom will be then 2 minus 1, which is 1. Then you can determine the p-value using this degree of freedom. So you're going to read from the table following the row for the degree of freedom for 1, and the p-value is the value that will correspond to 5% or 0.05. Okay, so the critical value, it's always this 5%, not 0.05. So how then we can analyze results? Anything that equals 5% or is above 5%, so we're reaching towards 100%, tells you that there is higher probability than 5% that the results are due to chance. Hence, there is no significant difference. You can accept the null hypothesis, and any difference on that side is just due to chance. But if your calculated value, okay, so here, okay, coming back because you might get confused. So if calculated value as the number, okay, so imagine like here the 5%, let's say, corresponds to number 8, okay, so the p-value equals 8, okay, but your chi-square equals 2, okay. So here, okay, your chi-square it's less than the p-value, okay, so there is a higher probability than 5% that results are due to chance. That's one option. But the other option would be that higher could mean as the percentage as well. So they could give you the p-value as 8 in comparing that with chi-square test, but they could say that p equals, for example, 0.5, right? So 0.5, that's 50%, okay? It could be this. So, or they could tell you that p equals 20%. So any value as given per percentage, okay, here it's in the same explanation, the probability is higher than 5%. But on the other hand, if the p-value, let's say, as the given percentage equals 0.1%, obviously this is then less than 5% chance that the results are due to chance. So there will be then the significant difference, and you're going to reject the null hypothesis. So the difference is due to other factors than the chance. But again, if they give you the value, for example, 10, okay, so your chi-square was 10, but the p-value was 8 as the number, not percentage, then obviously your chi-square is higher than the p-value, but you are still in the bracket here saying that there is less than 5% a probability that the results are due to chance. So those are the examples of the p-values given as the percentage here. You can convert that to the percent. So for example, here is 1%. So you're going to reject the null hypothesis. Here we've got 10%. So in that way, so you are going to accept the null hypothesis because the probability is higher than 5%. Right. So another test is a t-test, student's t-test, and this is to use when you are looking at the difference in the mean values. Good thing is you don't need to know this equation, but to work out the t-test, you need to know the mean values, you need to know the standard deviation, and you need to know the sample. So for the both values that you are going to compare. So t-test, same way you're going to calculate your t-value, but the difference in the degree of freedom will be now because you've got two sets of data that you are comparing, two mean values. So will be n, size of the first sample, plus n, not sample, but the cases in the first sample, second, minus 1. And then you can determine the p-value again in the same manner. So we're not going to look at this again because the idea is the same. You're comparing to 5%. Anything above the 5% towards 100, you are going to accept null hypothesis. Below 5%, you are going to reject. But as numbers, if they are lower, you're accepting. Higher, you are rejecting. So another test that we've got is a correlation coefficient, and this is when you are looking at the associations between different measurements. So here we're looking at the relationships. Tens of the degree of freedom n stands a number of pairs of data, and again you need to work out the p, compare it to the p-value. So same ideas but a little bit different wording. So in here you'll be looking at the correlations. So if the number is lower than the critical value, so we're looking here towards that 100% because the numbers are at the bottom, there is no correlation. So the probability is more than 5% that the results are due to chance. But then if the number is equal or higher than critical value, so again looking that way, but the percentage will decrease towards 0, then there will be a correlation and the probability will be less than 5% that the difference in those results is due to chance. So in a second part of this video, we will be looking at the examples, So look for the second video on the statistics. We will go through some of the past paper questions. Right, so that's everything. See you later.